Assalamu alaikum everyone. Hope everyone is doing great. Welcome to Mathematics with Shahab Yaqub. So now in today's class, the objective is to go over the chapter of probability. And probability is a chapter that people find it difficult. People find this thing that they have to look at the answer and they have to actually see whether they have done it correctly or not. So now let me just check my things and I think it's all good. Okay, so now let me share the screen and let me get started from here. So I'm sharing the screen. Just hold for a second. Let me check the net connection. That's on the wrong one. O-level math 4024. And what exactly is there in probability? So the first thing is, let's go over the syllabus and let me just get the syllabus from here. So this is topic number 8. Let me just capture the images. That is the first thing that we see over here. And let me paste it over here. Now, probability, when we use the word probability, there are some other words that come to mind. One of them is possibility. And the other word that comes to mind is chance. So probability is basically about what are the chances. What are the chances that it will be raining today? What are the chances that if I roll a dice, then I'll be getting a 5? What if I toss a coin? What is the probability? What is the possibility? What is the chance that I get a hit? So these are the different kind of things that we come across. So now if I look at the syllabus, it says 8.1, understand and use the probability scale from 0 to 1. I just want to check one thing that is right over here. And let me also add the rest of the syllabus so we can all have a good look at it in one shot. So let me paste it over here. Okay. So now it's about introduction to probability. So the first thing is the intro. Understand and use the probability scale from 0 to 1. I'll just first highlight them and then I'll go over each one of them. Understand and use probability notation. Calculate the probability of a single event. Understand that the probability of an event not occurring is 1 minus probability of that event occurring. Now, that is the first thing, that is the basic idea, that is the introduction. The second thing is relative and expected frequencies. Understand relative frequency as an estimate of probability. So, is there a difference between relative frequency and probability? We will see either in the first lecture or in the second lecture. Calculate expected frequencies. The third thing, that is probability of combined events. Calculate the probability of a combined event using a sample space diagram, a Venn diagram, a tree diagram. So let's get started with the idea that if I talk about the first thing, that is the introduction. So if I draw a number line over here, a thin number line, and this is the probability that it is the chance, there are 0 chances that such an event will not occur. So let me give you the example of rain. There is a 0% chance that rain will not occur versus there is a 100% chance that the rain will occur. So we know that percentage, fractions, decimals, they all are linked together, and we will study, or you have studied these things under the banner of numbers. We can convert percentage into decimals, we can convert decimals into fractions. So the probability thing, that is the chance. It could either be in percentage or fraction or decimal. 0% is 0 over 100, which is simply 0. 100% chance of rain, that is 100 over 100, which comes out to be 1. So what this first point is saying is that understand and use the probability scale from 0 to 1. That means probability lies between 0 to 1. 0, it means this is totally unlikely. This thing will not occur. And this is 100% guaranteed, or there is a very high chance, it's very, very likely that it will occur. So probability will lie between 0 and 1. That means, let me spell it out. That is probability, this is the shortcut that I'll use, can't be lesser than 0, which means probability cannot be negative, and at the same time probability can't exceed 1. So therefore probability lies between 0 and 1. Yes, it can be 0, yes, it can be 1, but it cannot exceed greater than 1 or lesser than 0. That is the first thing. Now the next thing is understand the probability notation. Now let me highlight it over here. So probability of A, P bracket A is the probability of A, P A complement, that is the probability of not A. And let me read further. Probabilities should be given as a fraction, decimal or percentage. I just talked about it. And what else is there? Probability problems may require to use information from tables, graphs or Venn diagrams, and probability of this thing, I'll just come to that in a short while. Now, first of all, we use the word event. That is about something is happening. So now when we talk about an event, let's say if I talk about a coin, I'm starting from the very basic. I know some of you will be having the midterm exams very soon, but let me go over it from the very, very basics, so that if I do some question related to tree diagram or sample space diagram or Venn diagram, so you should not get stuck at that. So if I talk about a coin has two faces. So there is a face, head, where the head of some famous personality or founder of that country is drawn. And the other one is tail, where something is usually written. So this is usually like a picture, and this is usually like a text or something. That is usually the case. So when we use the term fair coin, what does that mean? Is it fair in color? No, that's not what it means. Fair coin means unbiased, equal chances. So since there are two faces, a coin has a head, a coin has a tail. So the chances are 1:1. They are equal chances. That is what we mean by the term 1:1. So basic ratio is there also. Now, if I use the concept of fraction, 1 plus 1 is 2. So the probability P of H, which means probability of a head. So probability of head is 1 out of 1 plus 1, which is 1 out of 2. I can write it like this. There are two sides to a coin. One of them is head, the other one of them is tail. So probability of head is 1 over 2. Similarly, if I write P of T, which means probability of getting a tail. So probability of tail is also 1 over 1 plus 1, which is 1 over 2. In other words, when we are talking about a coin, and this is a fair coin, probability of head is 1 out of 2, and probability of tail is also 1 out of 2. Now, there are no other sides. There are only two sides. That means probability of head plus probability of tail should add up to 1. That means whenever something will add up to 1, it means all possibilities, all probabilities are considered. And that is the maximum that you can go. Now, let me use this notation. I'm just using the single diagram, the single example. Understand and use probability notation. Probability of A, probability of A complement. Now let me explain you the idea of A complement. Now, if I write probability of A, that means probability of A occurs. Now, instead of A, if I write head, that means probability of getting a head. Probability of getting a head. And if I write probability of H complement, so this thing over here, this is called complement, not the complement like the I compliment you, I appreciate you, not that one, the other one, the like in complementary angle, the opposite kind of thing. So H complement, it means probability of not getting ahead. Isn't that the same thing as probability of getting a tail? The answer is yes. Because there are two sides to a story, there are two sides to a coin. Either you will get a hit or you won't get a hit. So if the probability of H is half, probability of not H is also half. That means let me make up an equation, that is probability of A plus probability of not A should equal to 1. So this is probability of A, this is probability of not A, adds up to 1. That means probability of head plus probability of not getting a head should add up to 1. Isn't this the same thing as probability of tail? The answer is yes. So now that is the basic idea, that either something will happen or something won't happen. Let me illustrate this idea a bit further. Let's say probability that it will rain today is 10%. Probability it won't rain should be 90%, because we know that 100% is the same thing as 1. 10% is the same thing as 0.1. Let me just write the percentage separately. 10% is 10 over 100, which is 0.1. 90% is 90 over 100, which is 0.9. So probability of R plus probability of R complement won't rain is R complement should add up to 1. In percentage, it will add up to 100%. So 1 or 100%, it means the same thing. I hope it's all got all clear. Now, let me again go to that same paragraph. And it says, calculate the probability of a single event. I'll be giving some more examples. Probabilities should be given as a fraction, as a decimal, as a percentage. And then we'll be talking about tables and graphs or Venn diagrams and things like that. And this we just did. Understand, let me just highlight this. Okay, let me just clear this up. And let me just copy this thing from here. Okay, why is it not? Okay, now it's all good. So I'm just pasting it over here again. So now we have done this thing. That is probability. Understand and use the probability scale from 0 to 1. That thing is done. Understand and use probability notation. That's done. Calculate the probability of a single event. I'll be giving some more examples. Understand that the probability of an event not occurring is 1 minus the probability of an event occurring. That means I can write it like this. Probability of A complement is 1 minus probability of A. Good. Or probability of A complement plus probability of A should add up to 1. That's the same thing. Probability of something happening plus probability of something not happening should add up to 1. So that is what they're asking over here. Probability of B is 0.8. Find probability of B complement. Probability of B plus probability of B complement should add up to 1. It's easier to remember this. It's very basic. So therefore, this is 0.8. This is probability of B complement equals to 1. Therefore, probability of B complement is 1 minus 0.8, which comes out to be 0.2. All good, all clear? So now, let me give you the idea of a dice. So let me draw a dice first. So let me just draw a square thing. Let me draw a bigger one. Okay, so now this is one thing. This is 3 by 4. That's not good. Let me choose 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. That's a 4 by 4 square. Okay, and let me just draw this. Okay, and let me join this thing. Okay, let's say it's a 6-sided fair dice. Now keep in mind, a die is singular, whereas the word dice is plural, but things happen, we mix up the things. So I can use the word die or dice. There are 6 faces and a little bit of mensuration over here on which I'll be working very soon. There is the top, there is the bottom, there is the right hand side, there is the left hand side, then there is the front wall. So this red one, that is the front, and this one, that is the back. So imagine you are in a room and that is like a squarish shape, and this is a 6-sided die. Usually the numbers are, unless otherwise stated, 1, 2, 3, 4, 5 and 6. So these are the 6 numbers given. Probability of getting a 1. This is one number out of 6 possibilities. It's not just this is 1, it is one of them. So this is 1 out of 6. Same as the probability of 2, that is 1 out of 6. Same as the probability of 3. Same as the probability of 4. Same as the probability of 5. Same as the probability of 6. So all probabilities are equal. And that is how we get these values. Now again, if I focus on probability of getting a 5, that is 1 out of 6. Probability of 5 complement. What does that mean? Not getting a 5. That is 5 out of 6. Let me think of it from another perspective. 1, 3, 5. These are odd numbers. 2, 4 and 6. These are even numbers. If they ask me what is the probability of an odd number, so I'll say 1, 2, 3, that is 3 out of 6. Let's not just hurry up into simplifying the things. Just wait for a second till the very last step. And that is one thing that we learn in this. Probability of odd is 3 out of 6, and probability of even, that's also 3 of them. That is 3 out of 6. And again, the rule applies. Probability of odd plus probability of even adds up to 1. Even is basically not odd. That means I can write probability of O plus probability of O complement adds up to 1. Or probability of even plus probability of even complement should add up to 1. That is the same thing. So now that's the basic idea. And I think that is 8.1 is all done. Now let me move ahead and let me paste over here 8.2 and 8.3. So now 8.2, I'm not focusing, I'm focusing on 8.3. So let's get started with this idea. In 8.3, there are three things that we focus on. 8.2, I can do that a bit later. It says calculate the probability of combined events using, where appropriate, sample space diagram, Venn diagram, tree diagram. So let me get started with the concept of sample space diagram, and all the notations and everything, they will be used a little bit later. So over here, let me write sample space, and this is also known as possibility space diagram. So depends on the scenario, I can use the term sample space, I can use the term possibility space diagram. Now let's say there is a die and it's a fair 4-phase die, and the numbers on it are 1, 2, 3 and 4. I roll the die twice. Or even better, there is a red die and it has 4 faces, 1, 2, 3 and 4. There is a blue die and it also has 4 faces, 1, 2, 3 and 4. And both of them are fair. So there are 2 dice. There is the red one and then there is the blue one. And both dice are rolled together. If both dice are rolled together, we are looking at the numbers on the topmost faces and we will add them up. So we roll 2 dice. Let's say I get the number 1 from here, I get the number 2 from here. 1 plus 2 adds up to 3. And similarly, we have a lot of possibilities. So basically, the sample space is about those possibilities. We can draw them, we can list them, and these are the different ways of writing it out. So that is what we are focusing on. So let me write over here red die, and I have 1, 2, 3 and 4. And I have blue die and I have 1, 2, 3 and 4. And let me draw the line like this, and I'm drawing it out something like this. And let me write the red at the top. It doesn't make a difference. This is the red die. This is 1, this is 2, this is 3, this is 4. And similarly, I'm writing the blue die over here. So that is 1, that is 2, that is 3, and that is 4. So now let me just push this down. Okay. And there are different options over here. And let me write a plus sign over here because I'm adding that up. So now you can add in a particular order, but even before that, how many scores, and let me use the term, the topmost faces, add them up and let's call it the score. So the score is the sum. How many different scores do you expect? We expect 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are 4 possibilities over here. There are 4 possibilities over here. It's called a multiplication principle, a counting principle, and then we multiply it out. So now over here, when I add them up, So let me add them up horizontally. This one and this one, that is 2, and this 1 and 2, that is 3, and 1 and 3 is 4, and 1 and 4 is 5. That is how we add it up. And then we have this 2 and this 1, that is 3 and 4 and 5 and 6. And then we have 5, 6, 7 and 8. And then we have 5, and this is 4 plus 1 is 5. 3 and 1 is 4. So I think I missed out one of them, my bad. So let me write over here. 2 and 1 is 3, 3 and 1 is 4, 4, 5, 6, 7. And then last but not the least, that is 5, 6, 7 and 8. So these are the 16 possibilities that we get. Now let me highlight these. This 2 is occurring once. This 3 is occurring twice. So this is 1 and this is 2. And then this 4 is occurring thrice. This 5 is occurring 4 times. This 6 is occurring 3 times. This 7 is occurring 2 times. This red is occurring once. So let's go according to the colors, or I can just write it down, otherwise it will become too confusing. So let me choose this, and I'm writing down the different things and the probabilities. So now over here I have the score. The smallest score is 2. So 2 is 1 over 16. This is the probability. I'm just making a table listing all the probabilities. And then 3 is 2 over 16. There were 2 3s. 4 is 3 over 16. 5 is 1, 2, 3, 4. That is 4 over 16. 6 is 1, 2, and 3. That is 3 over 16. 7 is 1 and 2. That is 2 over 16. And last but not the least, 8. That is 1 over 16. So just to make sure that I've taken care of everything, let me add up. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Plus 3 is 13, 15, 16. I have taken care of all the possibilities. So just have a good look at it. I'll just pause for a short while. And those people who are watching, if they have any question or any queries, the comment section is there for you. So you can just ask me over there. So this is the basic idea over here. That is about writing it down. Now some people, they also prefer to write it down in this manner, that they can use the color red. They can write 1 and 1 and 1 and 1, and they can change the blue number. So 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. Similarly, I can start with the 2 series, that is 2, 2, 2 and 2, and then change the number of the blue, 1, 2, 3 and 4. Similarly, I can start with the 3 series, that is 3, 3, 3 and 3, and change the color, change the blue numbers, that is 3, 1 and 3, 2 and 3, 3 and 3, 4. And similarly, I can write the 4 series, 4, 4, 4 and 4. I can write over here 1, 2, 3 and 4. So I can write them as a bracket, as a coordinate. I'm just drawing all these brackets over here. And a lot of brackets. There are 16 of them. I hope you have counted it while I was putting in the bracket. 1, 1, 1, 2, 1, 3, 1, 4. Then 2, 1, 2, 2, 2, 3, 2, 4. And then 3, 1, 3, 2, 3, 3, 3, 4. That is 4, 1, 4, 2, 4, 3 and 4, 4. So over here, I have drawn a list of all the possibilities. So that is another way. But since they were asking the score, so that is why I was focusing on that. So that is the simple concept of a sample space diagram. Let me evolve it a bit further. And let me talk about, let me just draw up a question. And the question is, two fair six-sided dice are rolled. The score is defined as the product of the two numbers that occurs on the topmost faces. Draw a sample space diagram and hence list all the probabilities. So it's a basic idea that we are applying, and let me just draw this whole thing, not this thing, and hold for a second. So let me just put it in a box. Okay, so now this time there are two fair six-faced die, so it does not have to be colored. And I'm drawing a line like this. I'm drawing a line like this, and over here we are interested in the product. So let me write over here 1, 2, 3, spacing it out. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Now, how many possibilities do you foresee? There are 6 faces of one die. There are 6 faces on the other die. So 6 times 6, that is 36. 1, 2, 3, 4, 5, 6, and then 6 over here, 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 that is 36. So let me focus on this idea. When we were dealing with the red and blue die question, that was 4 by 4. There were 4 options for the red. There were 4 options for the blue. So the 4 into 4, that was 16 options. Now we are talking about die 1 and die 2. And this is 6 by 6. That comes out to be 36 options. Keep that in mind. The first question was about sum. The second question is about product. All good? All clear? So now when we have 36 options, let's fill it all up. So this is this 1 into 1. That's 1, 2, 3, 4, 5, and 6. Let me use this 2. That's the 2 table. 2, 4, 6, 8, 10, and 12. Let me use the third one. That is the 3 table. 3, 6, 9, 12, 15, and 18. Let me use the next one. That is 4, 4, 8, 12, 16, 20, 24. Let me use the 5 table. That is 5, 10, 15, 20, 25, and 30. And last but not the least, that is the 6 table. Let me use another color. That is this over here, the 6 table. That is 6. And this is 12, and this is 18, and this is 24, this is 30, this is 36. And again, they can ask you a lot of different possibilities. This time, I'm not making a table as such. I'm just focusing on different numbers. Now, I just need some more space. So let me just copy this thing and transfer it to the next page. And then the questions will be based on this. Okay, so let me just write it over here and let me make it a bit smaller. Okay, now over here, let's say if I am interested in what is the probability that the score, which is the product, the score is 12. Now, how many 12s do you see? I see a 12 over here. I see a 12 over here, I see a 12 over here, I see a 12 over here. So that is 4 out of 36. Yes, I can simplify. That comes out to be 1 over 9. That is the basic idea. How many? The score is 12. That is 4 over 36, which is 1 over 9. Similarly, if you ask me what is the probability that the score is at least 15. Now the word at least means it could be 15, it could be more than 15. So that means probability more than or equal to 15. Now how many 15s do you see? You see a 15, you see a number, another 15, next one is 16, 18 fills this criteria, 20 is there, 24 is there, 20, 25, 30, and then 18 is there, 24 is there, 30 is there, 16 is there. So all these ones are at least. Let me double check. That is, ignore this thing, the small one. Let's ignore the 12 for right now so that we can just focus on something. So this is 15. I forgot this 18. Yes, that is there. Let me just erase this. So 15 is there, 18 is there, 16 is there, 20 is there, 24 is there. This 15 is again there. And then we have this 20. We have this 25, 30, 18, 24, this thing and this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this comes out to be 13 over 36. Now let me write over here, probability score is lesser than 15. Can I use this thing? The answer is yes. The score is lesser than 15. That means this is the opposite of this thing. More than or equal to and lesser are the opposite. This is 1 minus probability. The score is at most, at least, not at most, at least 50. So this is 1 minus 13 over 36, which is 36 over 36 minus 13 over 36. This comes out to be 23 over 36. Is everyone clear on this? This is just like probability of A plus probability of A complement adds up to 1. More than or equal to 15, the opposite is lesser than 15. Let me also explain to you using a number line. So let's say there is a number 15 over here. And we are interested in at least 15. So let me use the purple thing. This is 15. And let me go this way. This is at least 15. And this is the number line for the score. That means less than 15, the next number could be 14 or 13 or 12 or anything all the way till 0. I mean, there is no 0 in the product. There could be a 1 over here. Yes, there is a 1. So therefore, this thing is the next one. This is lesser than 15. Of course, all the scores are integers. There are no decimals. There are no fractions as such. So lesser than 15 is this thing. So this probability plus this probability all the way till 36 should add up to 1. So that is the logic that I've applied over here. I hope this is all good, all clear. Now sample space could be done in a lot of ways. Let's move to the idea of a tree diagram. So let me just show you over here. What exactly were we discussing? That is, calculate the probability of combined events using, where appropriate, you have to make the decision. And how can you make the decision? You make the decision when you are well experienced, when you have solved a lot of questions. And in today's class, I'm just giving you a brief overview. And naturally, we will get that expertise when we will be solving the past paper questions. So now the next thing that I'm focusing on is Venn diagram. Let's focus on the Venn diagram. Instead of tree diagram, let's first focus on Venn diagram. So now Venn diagram is using set notation. So Venn diagram that is using the concept of sets. Now, I hope the concept is clear to you, but still, let me just focus on something. Let's say there is a universal set which is 1, 2, 3, and 4. There is a set A which is 1, 2, and 3. There is a set B which is 2, 3, and 4. And now my objective is to illustrate the data, the info on a Venn diagram. So what I'll do is that I'll draw two circles and let it be NT circles. So that's the first circle and this is the second circle. So let me write over here A, let me write over here B. Is there anything in common? Yes, there is. This number over here, 2 and 3, that is common between the two. So if I write probability of A intersection B, that is 2 and 3. So intersection means take common. So 2 will go over here, 3 will go over here. And what's left in A? In A, we are just left with this thing, which is 1. So 1 should go over here. And in B, what are we left with? We are left with 4. So 4 should go over here. So let me just highlight this thing also. That is 1 and that is 4. So I'll write over here, I'll write a 1, I'll write a 4. Make sense? If I talk about probability of A union B, so this U stands for union and this thing stands for intersection. The upside U, that stands for intersection. Intersection is take common. Union is take all without repetition. Do not repeat the common thing. That means if this is 1, 2, 3, this is 2, 3, 4, the common is 2, 3, 2, 3. So don't repeat it, just write it once. So this is the intersection thing. You have probably done the Venn diagram thing. So now over here, if I say that what is the probability of both A and B, that means we are talking about the common thing. We are talking about intersection. So if we are talking about intersection, there are two numbers. So I'll write this is 2 out of 4. There are two numbers out of 4. That is half. If I ask you, what is the probability that the number belongs to A only? I think the wording is a bit confusing. Let me just give you a better example. I mean, this example is good for the intersection. This example is good for this thing. That is the intersection, the common, the union. That thing is all good. Now, let me move on to the idea about subjects. So let's say there is option A, which is about math, physics, and chemistry. Let's say these are 3 A-level subjects someone is taking. Some people are taking option A, some people are taking option B. This is math, physics, and CS, computer science. Illustrate this thing on a Venn diagram. So if I illustrate it on a Venn diagram, which subjects are common? We have A, that is math, physics, and chemistry. We have B, that is math, physics, and CS. The common one is math. The common one is physics. So M goes over here, P goes over here. And chemistry, that is A only. That goes over here. And B is physics only. So not physics, that is CS. That is CS, computer science only. That goes over here. So that's how this Venn diagram is filled up. Now let me evolve this idea a bit further. Let's say let me make it like a worked example. There are 50 students in a class, and 30 of them take physics and 25 of them take chemistry, and everyone takes at least one of the two subjects, physics and chemistry. There is not a single person who's not taking any of the two subjects. So, I mean, they have to take either the physics or the chemistry. Illustrate the data on a Venn diagram. Now, this is like a word problem of set notation. And from this, I'll create a problem related to probability. So now, first of all, let me draw a box. Inside the box, let me draw a circle. Let me draw another circle. And there are 50 students in the class. First of all, this thing will be 0. What is this? This is for physics. This is for chemistry. This 0 over here means this. Everyone takes at least one of the two subjects. So there is not a single person in the class who is not taking physics, not taking chemistry. Such a person does not exist. Now, the second thing is, this is 50. This 30 plus 25, how much is that? That is 55. So how come it's more than the number of class? That means there are some people who are taking both the subjects. So now, if you have done set notation, let me write x over here. So physics only will be 30 minus x. And chemistry only will be 25 minus x. That means 30 minus x plus 25 minus x should add up to 50. Does it make sense? This one is physics only. They are not taking chemistry. These people are chem only. These people over here, this is both physics and chemistry. So now over here, if I want to add this up, so this negative x, this positive x cancels out. 30 plus 25, that is 55, minus x remains, equals to 50. Therefore, negative x is negative 5. Therefore, x comes out to be 5. 5 people are taking both physics and chemistry. Now, if I ask a probability question, what's the probability that a student takes both subjects? And which two subjects are we talking about? That is physics and chemistry. So I'll say that 5 is at the top, and altogether that's 50. So 5 over 50, which comes out to be 1 over 10. That is the answer for this particular part. If they ask me, how many people study physics only? So physics only is 30 minus x. So let me write over here, physics only is 30 minus x, which is 30 minus 5, which is 25. And chem only is 25 minus x, which is 25 minus 5, which comes out to be 20. So physics only, that is 25. Are both physics and chemistry, that is 5. Chem only, that is 20. Probability of physics only, that is 25 over 50. Probability of both subjects, that is 5 over 50. Probability of chem only, that is 20 over 50. I'm not reducing it. I know you're good at maths. You can do that. What about probability of taking exactly one subject. Exactly one subject is probability of taking physics only or probability of taking chem only. So probability of physics only is 25 over 50, chem only is 20 over 50. So 25 over 50 plus 20 over 50. First add, then simplify. That is 45 over 50. Not 45 over 45. This is 45 over 50. And this is 9, 5 nines are 45, 5 tens are, that is 9 over 10 or 0.9 or 90%. There is a 90% chance that the student is taking exactly one subject. So I think for today's class, that is enough for you to understand and store. So this is lecture number 1 of probability. Watch the video again, pause, jot down the things, and in the next class, which I'll announce soon, I mean, those people who have not yet subscribed, they can do that. Turn the notification on because I do keep a post on it, either on YouTube or the Instagram handle. And that's when I let people know that what are the days that we'll be studying this. Usually, I can just give you the idea that usually it will be Mondays and Wednesdays, unless something important comes in or urgently. This would be 7:15 till 8:15 approximately. This will be Pakistan Standard Time. This is when I'll be going live to teach you O-level math 4024. So till the next class, stay tuned for more content. Take care, everyone.